So we were asked to find the change of an angle, or a viewing angle, as a guy walks from a theater screen to 30 feet. And we're given that the top of the theater screen to eye level is 10 feet, and the bottom of the theater screen to eye level is 3 feet. We need to find our theta angle. We don't know this angle, and we don't know this angle, but we can still label them. This angle we're going to label as A, and this angle we're going to label as A plus theta, since this whole angle is theta plus A together. And we're going to label this distance between the theater screen and the guy as X. So we need to find our basic relationship. Our basic relationship is cotangent, because cotangent equals the adjacent over the opposite, and we have adjacent over opposites. So the cotangent of A will equal x over 3, and the cotangent of A plus theta equals x over 10. And we can solve for both of these angles by taking the inverse function. So A will equal the inverse cotangent of x over 3 and A plus theta equals the inverse cotangent of x over 10. So we need to take the derivative of, or in order to find theta, we need to take this whole angle and minus this angle. So we have theta equals the inverse cotangent of x over 10 minus the inverse cotangent of x over 3. And we're not asked to find theta. We're asked to find the derivative, the change in theta. So we need to take the derivative of theta and this angle and this angle. So the derivative of theta is going to be d theta over dt, and d theta dt of inverse cotangent of x over 10 minus the derivative of the inverse cotangent of x over 3. So the derivative of the inverse cotangent is 1 over 1 plus x squared times the derivative with respect to time of x over 10. So that's 10x prime over 100 minus, and the derivative of the inverse cotangent is actually a negative, minus the derivative of the inverse cotangent, which is 1 over 1 plus x squared, times the derivative of x over 3 with respect to time. So it's 3x prime over 9. We can simplify that down a little bit to have the derivative with respect to time equals 10x prime over 100 plus x squared. Take away a negative, and this is actually a negative 2. So take away a negative, so we'll have plus the derivative, to simplify this down, is 3x prime over 900. Sorry, this is supposed to be 900. Oh no, it's not. Sorry. 9 plus x squared. So, we know that we're given x, which is 30 feet, and we're actually given x prime because we're moving at 3 feet per second. So we can replace 3 and 30 with our variables. So the derivative of theta with respect to time equals 10 times 3 over 100 plus 30 squared plus 3 times 3 over 9 plus 30 squared. Which simplifies down to the derivative of theta with respect to time will equal, and this is again negative, negative 30 over 1000 plus 9 over 909, and that simplifies out to be the derivative of theta with respect to time will equal negative 0.0201 radians. So we're moving away from the screen, that's the reason why it's negative, at 0.02 radians per second.